My name is Ann Lynn. I work at the University of Wisconsin in the College of Engineering. Today we're going to talk about how scientists and engineers who work with really small things like DNA or viruses or atoms can measure very small amounts of things. Maybe you've heard someone use the term 1 ppm or 1 parts per million. This is used to measure things like pollution in water or the air. For example, the amount of chlorine in a swimming pool is about 3 parts per million, which means about 3 milligrams per liter of water. We're also going to talk about 1 parts per billion, so that means 1 unit of one solution in a billion parts of another solution. Today, we're going to make solutions that are 1 part per million and 1 part per billion using a technique that scientists use called serial dilution. For this activity, you're going to need some containers, 10 containers. And I'm going to use these clear plastic cups that we got at the grocery store, or these tiny clear plastic cups. So everyone has 10 cups. We're also going to need something to make the dilution with, so you'll need some water for that. Finally, we need the thing that we're going to dilute. So Hannah is going to use this food coloring, and I've chosen green because it's a dark color. This way we'll be able to see the effect of the serial dilution. So Hannah will do food coloring. I also have some flavoring here. This is almond extract, which has a very strong scent. And you can use anything that really smells strongly. For example, mint or almond or lemon. And Noah is going to use the almond extract. Finally, I'm going to use some apple juice concentrate so that we can taste the different dilutions. You're also going to need something to be able to measure out volumes of different solutions. Now, if I were in my laboratory, I have special tools, graduated cylinders, and other types of measuring tools where I could really accurately measure the amount of the solution. Since I'm not in the laboratory, I'm going to use the things I have around the house. So for example, if I were going to make very small amounts, I might use an eyedropper like this one that you might get in children's medication. Or we could use some standard kitchen measuring spoons, such as these, or regular measuring cups like the ones I have right here. So anything you have that can be used to measure, even a medicine cup, which has gradations, could be used for measuring, is going to work fine for this. And what we're going to do is we're going to put 9 parts of water into each of these cups after we label each cup. So everyone will take a marker and label their cups from 1 to 10. For each of these dilutions, what we're going to need is 9 parts water and 1 part of the material that we're diluting. We need to put the same volume of water in all of these cups, and there are 2 different ways that we can do this. So for Hannah's little cups, she could add 9 1/4 teaspoons of water to each of the 10 cups, and then when we start the dilution, she'll add 1/4 teaspoon of the material, in this case food coloring, that she's diluting. Another way we could do this is multiply 9 by 1/4 and get 2 1/4 teaspoons, and we could add 2 1/4 teaspoons of water to each of the cups, which means that we'll just do a little bit less measuring. So we'll go ahead and add the water to each of these cups now. Again, the volume doesn't matter as long as the amount of water is 9, and then you're going to have 1 of the solution. So 9 times a 1/4 cup and then a 1/4 cup of the solution, or 9 times a cup, 9 cups, and then a cup of the solution. It doesn't matter how much you make as long as it's 9 parts water and 1 part of whatever we're diluting. But don't add what we're diluting yet. That part comes next. So go ahead and add the water to your cups. After you've added water to all of the cups, you're going to want to take a look and make sure that the water level looks approximately the same, especially if you chose to do 9 individual measurements. Now we can use our eyes to look at the water level, but it won't work if we look down like this. So what we're going to do is we're going to get out of our seats and make sure that our eye is aligned with the water level in the cup. So if you look at all the cups, yeah, the water level looks pretty good in mine. Now we're ready to start our dilutions. What you're going to do is take the liquid that you're diluting, so apple juice, almond extract, and the food coloring, and you're going to get 1 measuring spoon of that. So I use tablespoons. I'll get a tablespoon of that. Hannah, what did you use?
A quarter teaspoon.
All right, so Hannah's going to use a quarter teaspoon of food coloring, and Noah?
Also a quarter teaspoon.
Noah's going to add a quarter teaspoon of almond extract. And we're going to add this to cup number 1. So go ahead and do that. And then stir it up. So now what we're going to do next is we're going to take 1 tablespoon in my case, quarter teaspoon of the solution in cup 1 and add it to cup 2. So 1 measuring unit out of cup 1. And, oh, glad I labeled these because they got mixed up. Pour mine into cup 2 and stir. Yep. Great. Then you're going to take 1 measured unit, again tablespoon in my case, out of cup 2 and add it to cup 3. You'll keep doing this all the way until you get to cup 10. So this chart shows us the dilutions that we made. So we have the number of the cup, how much of the solution, and in our case, either food coloring, apple juice, or almond extract, how much water, and then what the dilution is. By the time you get to cup number 6, you can see you've made a solution that's 1 part per million. And then if you go down to cup number 9, you can see that you've made a solution that's 1 part per billion. And depending on the age of the kids that you're working with, you may want to have them do this math to figure out what the different dilutions are. So, Hannah, what observations are you making about these solutions?
I like the 6th one. You can't really see the color.
Yeah, even on the white paper, maybe a tiny bit. Noah, what do you observe?
Well, the color dies out really fast.
Yeah, it's interesting to me that cup number 1, which is a 1 to 10 dilution, and then cup number 2, which is a 1 to 100 dilution, they don't really have much difference in how they look, do they? Mm. Yeah, so the next thing we can do is we can look at Noah's, and, well, not look at them because they all look the same, but let's smell Noah's and see where the limit of our ability to sense something by smell is. Now for Noah's, since we're going to try to smell the solution in each of these, we need to start with the most dilute, because if we start with the least dilute, then everything is going to smell to us. All right, so you smell first since it's yours. Can you smell anything in that?
Not really.
No, me neither. Okay, just keep going. Yeah, so we think maybe we could smell it in 4, but you couldn't. So that's interesting to me that for the color, we couldn't see it after 5 or 6, but for the scent, we couldn't see it after 3 or 4.
Smell it.
Smell it, sorry. We couldn't see it in any of them, but we couldn't smell it after 3 or 4. So this next one is taste. Does it taste like water? I appreciate your tasting.
Oh, I know I can taste apple juice in that.
Oh.
Definitely apple juice in that?
Yeah.
This one might be really sweet because it's not the correct. So you can try many different things. If you want to try something with a stronger flavor, maybe you try hot sauce. Just be careful as you get to number 1. Mint extract might have a strong smell, so you might be able to smell it in the more dilute solutions. This is how scientists dilute things down to very, very small amounts. Thanks for joining us, and check the comments for a copy of the worksheet.